So moving on to the first law of thermodynamics now. So the law talks about change in internal energy. That's equal to heat minus the work done by the system. Okay. So we need to understand each of these terms, internal energy, what is heat, work, and all of this. Then we will circle back to the statement again. So we'll start off with internal energy. Internal energy is all the microscopic energy of a given system, right? That is associated with the atoms and the molecules. All of this is measured with center of mass being at rest, right? So the center of mass is fixed, and we see all the systems particle, how they are moving, what is their kinetic energy, potential energy, and so on and so forth. Okay, so there's a lot of details that we need to understand. So what internal energy includes, we talk about the microscopic kinetic energy of the molecule. That includes random translation motion, rotation, and vibration. Okay, so please borrow your understanding from chemistry. It will make more sense. So this is an extension, or we're looking at this in the next chapter, actually, next chapter. So again, we'll be looking at the entire thing, but with a different chapter heading. Potential energy stored. So within molecules, there's chemical bonding. Between molecules, we have internal molecular forces. So all of this put together makes up your internal energy. What internal energy does not have, that also we need to understand. So this goes back to the point that your system center of mass is fixed. Your reference frame is your system center of mass. So with that being 0, even if the entire system is moving, right, as a whole, we are not going to consider the motion of the entire system as a whole. Any bulk kinetic energy of the system, due to its motion through the space, right, that is ignored, because center of mass is fixed, right? Whatever is happening with the center of mass is ignored per se. The system as a whole, whatever is happening with it, it's ignored. If the entire disk is rotating, it's ignored. Please understand that. Macroscopically, whatever is happening, if there is a potential energy, if the system is made up of something and it's above the ground, we ignore that gravitational potential energy. But what we include is between molecules and within molecules, the chemical bond and the internal molecular forces. We are considering those forms your internal energy. Please understand the difference over here. Remember, close your eyes, take a second. Let's go back to the very first set of slides. We spoke about system and the surrounding, right? System has a boundary, and we are looking at certain set of materials that it's made up of. Especially when we're talking about all of this thermodynamics and everything. So all of this comes into picture. Okay. So you will see why is this important. We'll see this in heat capacity, latent heat, like melting an ice, boiling water. So again, we'll see all of this repeatedly, but it's important for us to have the picture, take it forward, take all of it forward. So we understood about system and the surrounding, right? Then we looked into different types of system, closed, open, isolated, and all of that. Is it not? And then we spoke about different terminologies, right? Okay, so we have a clear understanding of a system and surrounding. Whatever is happening within the system is what we are considering. All the energy within the system is what being considered, but system as a whole, if it's moving through the space, that kinetic energy or potential energy is not considered. So these things makes up the internal energy. Now, heat is quite simple. Heat is not the property of the system. Heat is a process. Okay, energy in transition, not energy stored. Heat is a process. When we again, heat also we'll look at it in detail. But heat is when we have the energy being transferred from point A to point B because of difference in temperature. So for now, you just have to know that heat is not a property of a system. Heat is a process. Okay. So with this, let's come. Okay, one more thing: sign convention. So sign convention for heat and internal energy. If you see heat to be more than 0, heat enters the system. If Q is less than 0, heat is leaving the system. So energy is going out, energy lost, right? Here the energy is gained. Heat is a process. Remember, heat is a process. Work, if it's more than 0, work done by the system. If work is less than 0, work is done, work done on the system. If we do work, we are losing. If work is done on us, we will gain energy. The system gains energy, right? So this difference has to be known. When Q is greater than 0, W is greater than 0, there is here you are gaining energy, here you are losing energy. That difference has to be very clear. So with all of that in mind, first law relationship states that the change in internal energy is equal to heat minus the work. Okay. So if I'm gaining heat, so it's positive. If work is done on the system, so this is negative, negative of negative becomes positive. So the change in internal energy is incremental, it increases. Okay, both these are adding up. Now the conceptual statement, energy can neither be created nor be destroyed. It can only be transferred from one form to another. So thermodynamic statement, the change in internal energy of a system is equal to the heat added to the system minus the work done by the system. The same thing in a statement form. Okay, so again, this is an overview. All of this is an overview for the next chapter. All of this will be done in detail eventually. Okay. So term definition and units. Okay, so we looked at first law and second law in short. So the zeroth law and first law in short. So zeroth law deals with defining temperature. It leads to definition of temperature. You have thermal equilibrium and all of that, right? And it's very commonsensical. Here you're talking about work, energy, and all of that. So here in specific, we need to define internal energy, heat, work. Okay. So the system gains energy, the internal energy increases if heat comes in or work is done on the system, right? So that is commonsensical, and all the other possibilities you guys can imagine. So for now, have a look, write. Eventually, we'll be understanding a lot more about all of this.